Hello students, today we are going to start a new chapter. Hope all of you have completed chapter number 5, refraction through lens. Okay, now before I start the next chapter, see, we all are well aware of this term sound. In our daily life, we hear different sounds, right? From sources like our electric bell or telephone ring, right? Or we can think of our school bell. Okay, everything, if a fan is moving, it produces some kind of sound. Okay, any rubber band, if we stretch it and then we pull it and pluck it and leave it, it starts vibrating and it produces a sound. And not only these, also any type of musical instrument, if I take guitar, tabla, right, what happens is basically these are the instruments which produce sound. Now today in this chapter, new chapter sound, we are going to study in depth the various characteristics of sound, terms related to a sound wave, what kind of wave sound waves are, right, and many new concepts. So let us start the topic with the very first thing, that is what all we are going to study in the first part is what are sound waves, okay, what is the frequency range for audible, for ultrasonic, infrasonic, reflection of sound waves, echo and uses of echo. Let's start class. What is sound? Sound is a form of energy that can be heard and travel in waves. Okay. See, what happens is, we all know all around us there are air particles. Okay. Now you must have seen also when very through a very small slit, some opening is there and sunlight comes, a beam of sunlight comes, enters your room. You must have seen randomly moving particles, right? Air particles. So these are actually the air particles which carry some energy. Whenever a person speaks, the other one is able to hear that sound with the help of ears, because there are particles present in between, and whenever the sound is produced, the particles, they there is some kind of disturbance which is created among the particles, and that disturbance is passed on in the form of energy from one particle to the another, and hence it reaches the ears. This is a very general basic concept. Okay, so what is it? Sound is a form of energy. The way we hear light energy, light is a form of energy, wind is a form of energy, and many more. So sound is a form of energy that can be heard and it travels in the form of waves. When matter vibrates or moves back and forth very quickly, a sound is made. See, it is very, very important, this red word is vibrate. Any body which vibrates produces a sound. You can keep your hand on your vocal cord, right? And what you can observe is, whenever you speak, whatever you utter, there is some kind of vibration, there is some kind of sensation of vibration which you can feel on your hand. The reason is, again, there is vibration which is producing this sound, right? So next is, sound waves can travel through solids, liquid and gases. We are going to talk about this. Let's take one by one the examples. Solids, you have taken the chapter sound in previous class 9th also, and there we discussed these railway tracks, right, the rails. What happens is, when the train is about to come, before you see it, you are able to hear that sound which is traveling through the iron rails. That is it. A simple example which proves that the sound waves travel through solids. Next is the liquids. The sounds which are produced in the form of sonar, or we can say which are produced by the dolphins and all, they're audible. The reason is, the sound can travel through liquids. Somewhere in, they all use this concept, liquids, when the sound is traveling. Okay. Last is the gases. Yes, we all know the example. Common example is, I am speaking, you are able to hear because gases, the air particles are present in our atmosphere and the sound is traveling. So sound can travel through all the three mediums, solid, liquid and gases. Okay. Let's talk about next, that is, there is an example. When a school bell rings, parts of the bell vibrate, creating sound. This is a very common experience. You must be able to understand. Now, see, there are various examples. Okay. First example which I have taken is, if there is a gift and there is a chain of students standing like this, and it is to be passed from first to the last, what is the method? It can simply be passed from one child to the another. Exactly same thing happens with the particles also, air particles also. When a sound is produced, see this is the way how the particles are arranged. When a sound is produced, what happens? The air particles, they arrange themselves into a pattern like this. At places, the particles come closer to each other. This is called compression. At places, the particles move apart from each other, away from each other, which is called rarefaction. So this is how the waves are formed, and such a waveform we obtain of the air particles, right? Okay. Now, this we have understood so far. What is sound? It is a form of energy that can be heard, and it travels in the form of waves. When any matter vibrates, anything which vibrates, it produces sound, moves back very quickly, and sound is made. Sound waves can travel through all the three mediums, solid, liquid, and gases, and the example which I have taken. This we have understood so far. Now let's talk about this important term. This too we have discussed in class 9. Range of audibility, if you remember. Fine. See, in bio you study ear complete, right? Complete structure of ear, eye, all that you have studied. So what happens? These all are biotechnical parts. We are just going to take the physics part. What happens? A sound is produced from a source. There are air particles present in between. The air particles, when the sound is produced, arrange themselves in a pattern. At places they'll come closer, at places they will move apart. And these energy of the sound is transferred from the source of sound to the ears, right? Which goes inside the part, and then there are three bones. You must have studied this in bio, and ultimately it reaches to the brain through the nerves, right? Now what we have to understand here is the range of audibility is, it's not that all the sounds that are produced are audible to us, okay? Below 20 hertz, the sound that are produced, these sound waves which are having frequency below 20 hertz are considered as infrasonic or infrasonic, okay? Next comes above 20,000 hertz that are heard by bat, dolphins and all, they are ultrasonic. Sonar, they use ultrasonic. Okay, so ultrasound is above 20,000 hertz or 20 kilohertz, because 1 kilo is 1000. And the one which lies in between, this is the one which is audible to us, 20 hertz to 20,000 hertz. This is the sound wave which is audible to us. So here the examiner can ask you the question, but the sound wave, there is a sound wave having 18,000 hertz frequency, will it be audible to us? Is it that the sound wave of frequency 22,000 hertz audible to us? If yes or no, why? So accordingly you can answer this. Fine. Now let's move to the next part. When we are talking about the sound waves, we are discussing a wave pattern, okay? A wave pattern we are talking about. Now there are many terms which are related to this wave pattern. Let's understand if this is a simple wave I am talking about, okay? See, one crust and one trough. This completes one single wave. Again I repeat, one crust and one trough. What is crust? This above part of the wave. This below part is called as the trough. So one crust and one trough, it forms a complete wave. Okay. So let us now discuss each of these terms one by one. Okay. Amplitude, the first one, the maximum displacement of the particle of the medium on either side of its mean position. This horizontal line, students, if you all can see, is basically the mean position. So from this mean position, whatever is the maximum displacement above or below, it will always be the same. So that maximum displacement is termed as, is called as the amplitude. Time period, capital T. The time taken by the particle medium to complete its one vibration. One vibration, let me speak it once again for you. It means one crust, one trough. One crust, one trough. So that is one vibration. So whatever is the time taken to complete one vibration, that is called time period. Amplitude, its unit is meter. Time period, second. Frequency, the number of vibrations made by the particle in 1 second. In 1 second time, whatever are the number of vibrations that are made by a particle, that is called as frequency. Frequency is equal to 1 upon time period. So the unit of frequency is either hertz or per second. Fine. Next is the wavelength, lambda. This we have discussed in chapter 4 also. Wavelength, lambda. It is the distance between distance traveled by a wave in one time period, we can say, or the distance between the two consecutive crusts or two consecutive troughs. So that is called as wavelength. Last is the wave velocity, the distance traveled by a wave in 1 second. We all know velocity is what? Distance upon time. So the distance traveled by a wave in 1 second, that is wave velocity. Clear, student? These all terms are very, very important. You need to Know these definitions very clearly. Let me take you to the next now. Yeah. Next is how sound waves differ from electromagnetic waves. So this is the difference between, you got to prepare yourself and write down the same. Okay. Now moving to the next part, mechanical waves. Some of the waves must have substance to which they can travel through and few which cannot. So mechanical waves must have material medium, that means they require a medium for its propagation. Sound waves, we all know light can travel through vacuum and sound cannot travel through vacuum. So sound waves are mechanical waves, they require a medium. Okay. The material that waves travel through is called the medium. Correct. Now sound waves we all know can travel through solid, liquid or gases, and ocean waves travel through water, that is the liquid part. Now comes the longitudinal and transverse waves. See, when I am discussing this, we are talking about two types of waves. One where crest and trough is formed, one there is a, this is the crust and trough being formed, so that is a transverse wave, and the part, that particular wave which is having compression and rarefaction, that is termed as longitudinal wave. So easy to understand this particular pattern. Okay, when you have crust and trough being formed, that is a transverse wave, and whenever we have the particles arranged in such a way that compression, that is the part where the particles come closer, rarefaction where the particles are moving away, so such a wave is called longitudinal wave. Clear? The difference should be very clear, students. So that's why I've shared this particular image with you. Now the next is echo. See, the way when light strikes a surface, bounces back, sound also does the same. When a sound is produced, what happens is the sound strikes the surface and comes back. Okay, and whenever that sound is heard back, we term it as reflection of sound or echo. So the sound heard after reflection, this reflection word is exactly same, having same meaning as that reflection of light. The sound heard after reflection from a distant obstacle. It is important to note here, it is not that you are speaking in a room and you are able to hear echo. No. What all is needed is there are few conditions also, such as a cliff, a hillside, wall of a building, edge of a forest, etc. These all are important. After the original sound has ceased, that means the original sound must completely, yes, completely cease. Okay, then the second sound, the sound which is heard is called as the echo. Clear? Reflection of sound. So the laws that are followed by the reflection of a light are exactly the same as for the reflection of sound. Angle of incidence equal to angle of reflection. The incident ray, the reflected ray and the normal ray are the same plane. Okay. Then what is the difference or reflection of sound waves? The returning back of the sound wave on striking a surface is reflection of sound. The only requirement for this is the size of reflecting surface must be bigger than the wavelength of sound. This is an important condition. Now these are the three important conditions we can talk about. One, the minimum distance between the source of sound and the reflector in air must be 17 meter. This question comes in the exam straight away. It is there in class 8 and class 7 also. Three conditions for echo to be heard or reflection of sound. That is number one, the minimum distance between the source of sound and reflector should be 17 meter. Even if it is 16.5, no echo will be heard. 17 meter minimum distance. So there comes a question where the value of the distance comes out at 16.5 meter, and then the students were asked that whether the echo will be heard or not. No, because the minimum distance is 70 meters. So this is an important point. Next, the size of reflector, just now explained you in the previous part. The size of reflector should be large enough as compared to the wavelength of sound wave. Third, the intensity of sound should be such that the reflected sound reaching the air is sufficiently intense to be audible. Okay, once the original sound has ceased, which is 0.01 second, the original sound actually takes 0.01 minimum time to cease, and then after that the sound which is heard is termed as echo. So that is an important point. Okay, uses of echo. Yes, I have discussed you since beginning. Dolphins, they produce a sound, and that is the ultrasonic sound. Okay, bats, how do they locate their obstacle in the prey? They are not able to see. What do? At night they produce some sound. That sound strikes the obstacle and gets reflected back. That reflected back sound is heard, that echo is heard by the bat, and that makes him understand that at what distance the obstacle or the prey is there. Fine. Same with the submarines. They produce a sound. It reflects, strikes the surface, gets reflected back, and then that echo is heard. So its uses are by bats, dolphins, fishermen, given in your book properly. Each one is given, okay, the explanation part, and all are important, let me tell you. So I'm sharing the parts also, the bats, dolphins, fishermen, how they use the echo concept, reflection of sound. So this is important. What kind of sound waves these are? Everywhere it's ultrasonic. Remember student, it is ultrasonic. This is uses of echoes by sonar. I've just shown you because in your book the images are not clearly shown, so that is what I have used for. Okay, other than that, that part is explanation part is completely there in the book. So you can see that the sound is produced, it strikes the surface, it is getting reflected back, and the receiver hears it and gets to know that where is the object, we can say, or the second submarine, kind of that. Okay, last is the medical science. Yes, medical science also, high frequency sound waves reflect off the baby tissue in the womb. So that is ultrasound. We all, USG is the short form is used, which is used to ultrasound is done, okay, for that reason. So it is important in medical science. This is also important, cardiography, electrocardiography, right? So for that also it is done. Fine. So these are the common example for the uses of echo, which is very very important in our daily lives. So all this must be done by you. Okay, we'll continue with the rest in the next class. I'm sharing with you a image, and in that all the notes are given, must complete all the notes. Okay, thank you.